This is a homework video for lesson 1-7, and I'm just going to work through all 5 of these problems. So this is number 21. I went ahead and got a start because I'm going to graph these boundary lines by plotting intercepts. And so what I've done just to kind of get the ball rolling here is you can see I went ahead and solved the top, treat it as it's an equation. I solved the top equation form for x and got -5. Y is 3.75. And so the intercepts for I'll do this first one in red, the intercepts for that top inequality are going to be -5 on the x-axis and +3 3/4 on the y. And that will be a solid boundary line. And I'm just going to do all the shading after we've finished putting all of our lines, boundary lines, on the graph. So I'll see if I can hit both of those. Looks pretty good. All right, now in blue, I'll plot the second inequality. The boundary lines are, the intercepts are x -2.4, just about to -2.5, and then y is -6. There, and this is going to be a dashed boundary line because it just says greater than. So let's see if I can connect these. Try that again. Okay, I just paused the video and I like that a lot better. So there's the blue boundary using those intercepts, and now we'll go to green. And we'll plot an x-intercept of 2.2. That x line is not showing up very well, but it's right there. So just to the right of 2 on the x, and then down here at -6 also y. And now we'll connect those, and this will be solid. Let's see if I can connect these. All right, so looks like we got our boundary lines drawn, and we'll do all the shading. So for this red, we will be shading below. For the blue, we will be shading above. And for the green, we'll also be shading above. So you put all the shadings together, and you should be shading inside this triangular region. Just going to highlight it in yellow. And then we got to identify, for this one problem, you're going to identify the vertices. And so I know this one without a doubt. I have this vertex at 0, -6. No problem there. There are questions about this one, maybe just because I didn't line the points up well. It's kind of hard with this board. And then I've also got questions with this one. So whenever there's a question, this is where algebraic methods come in handy. So I'm just going to let the green equation, so green is -3x plus 4y equals 15. And I'm going to put that together with the red equation. I'm sorry, that was the red equation. The green equation is below that. So -27x plus 10y equals -60. Okay, and if we want to know where these two intersect, then elimination or substitution will tell us exactly. So I'm going to multiply the top equation by -9 so I can eliminate x. All right, so 27x minus 36y equals 15 times -9, and that's -135. And I don't have to do anything to the bottom equation. Okay, and now we can add, and -36 plus 10 is -26y, and this makes -195. So 195 divided by 26 is 7.5. So the y coordinate of that point, let's see if that's reasonable. 1, 2, 3, 4, 5, 6, 7. Let's see. 1, 2, 3, 4, 5, 6, 7.5. It does not look like it's too close, but again, it could be because of my lines not lining up. Okay, let's see what the x coordinate is if we plug in 7.5 for either one of these y's. So -3x plus 4 times 7.5 is equal to 15. So 4 times 7.5 is 30. -3x is -15, so x is +5. See if that looks reasonable. 1, 2, 3, 4. 2, 3, 4. Looks like my lines are way off. So the actual intersection of that point should be the point 5 and 7.5. So hopefully with your ruler, you can get more exact with your lines than what I'm doing here. But at least hopefully watching this, you can see how using intercepts you can come up with those boundary lines. And then we'll do the same thing for the intersection of red and blue. Since I can't really tell for sure, we'll put the red and the blue together. So -3x plus 4y equals 15. 5x plus 2y equals -12. Using elimination, I'm going to multiply the bottom by -2. And that's -10x minus 4y equals 24. So -13x equals 39. X equals -3. 2, 3. That looks good. And now we'll get the y by plugging that into either one. I'll just use this bottom one. -15 plus 2y equals -12. 2y equals 3. Y equals 1.5 or 3/2. And that looks reasonable. So this part looks a lot better being drawn than this one does. So I may have counted the space wrong or whatever, but the graph looks good. We've identified exactly where the intercepts are. We did the shading. We identified everything that we needed to do. So that is number 21. All right, let's take a look at our second problem. This is a combination of an absolute value inequality with a linear inequality. So to graph the absolute value inequality, here's a case where you're going to utilize that formula that I showed you in class on how to find the vertex of the V. So here's that formula again. Comes in handy whenever we're supposed to sketch a version of the parent, not the actual parent. It's good to know exactly where that vertex is, and then it's pretty easy to graph the V from there. So the number in front of x is always considered m in this formula. The other number inside the absolute value is b, so you can kind of see y equals mx plus b. And then you've got this other number outside being added or subtracted called c. So if we use our formula, the opposite of b over m, that's 4 over 2, and then c is negative 2. So that means the vertex of our v is going to be negative 2, negative 2. All right, we'll just do the v in red. So let's start at negative 2, negative 2. And then from there, we're going to count a slope of 2, both positive and negative. So up to right 1, up to right 1. And then go the same thing with negative 2. And this is going to be a solid V shape. So I will switch the type of line that I use. Make sure it's solid. We're doing this in red. And here's my V. And then the shading, when we do the shading, it will be greater than, means above the line. So we will be shading everything inside the V. All right, we'll do this one in blue. So you could do intercepts, you could solve for y. Ones like this, it's easy enough just to go ahead and get it in slope-intercept form. So dividing by 3, multiplying by 1/3. There is our slope-intercept form. And we start with an intercept of positive 5. Then a slope of negative 1/3, so down 1, right 3. Or up 1, left 3. And this is also going to be a solid line. Change this one to blue. Looks like that. You want to extend so that you have a chance to actually intersect, and it's that one too. So I think it's because some of my lines aren't showing up real good. Looks better. All right, so for our shading, we're going to be shading above the red, but below the blue. So that means everything in this area. Any ordered pair that comes out of the yellow would be a solution. It would make both of the inequalities true. And that's what it takes to be a solution to a system. It can't just make one of them true, it has to make both. Now, on these, you don't have to come up with vertices, you just have to graph. The only one that will require vertices is that first one, number 21. All right, so there's your answer for 28. Here's number 30. This is kind of odd, number 30, because normally, oh, go back to my pen. What's normal is to see this as y is greater than or equal to the absolute value of x. So this is not something I would test or quiz you on, but just in case you want to know. So in other words, when I plug numbers in, this is just the parent v. Let me just kind of illustrate it by doing this first. I think we've talked about this parent v that has these points, up 1, right 1, up 1, left 1, vertex at the origin. So that means if in equation form, looking at the equation form, if we do an input of 1, we get an output of 1. If we do an input of negative 1, we also get an output of 1. Okay. Well, this is kind of turned around, and it says the absolute value of y, and we'll look at the equation form, is equal to x. Okay, so 0, 0 still, if if x is 0, the absolute value of 0 is still 0. Okay. So if x is 1, for example, that could be, to get 1, y could either be positive 1 or negative 1 because of the absolute value. So there's really two options for y for this 1x. So it's kind of like this. Instead of being a v that opens up, which is what we're used to seeing, it's just kind of think of it as I could get 1, 1 out of this. I could also get 1, negative 1. 1, 1 is here, 1, negative 1. So without going into too much detail, every time we do an input, like 2, we get two possible outputs, 2, 2, and 2, negative 2. So this is going to be the V that opens to the right from the origin. All right, so just wanted to illustrate that. That's not something we covered in class, but you could figure it out by doing inputs and outputs. Anytime you want to figure out what a function is doing, you can test with inputs and outputs. All right, so it's going to be a solid V. And when I do the shading, because it says greater than, y is greater than, remember greater than is above the line. So when we do the shading, you're talking about everything up here and here outside of this right opening V. And then to do our next one, we'll do this one in red. Think about the boundary line y equals 2x. All right, y-intercept 0, slope of 2, up to right 1. And it's going to be a dashed or a dotted line. This one in red. The shading for the line is less than, which is below the line. So we already said we'd be shading outside of the V below the line, or greater than is above the line, but red is below because it's less than. So basically you're talking about the area in between. This area between the blue and the red. And there's your answer for number 30. Okay, 32 is another 3 inequalities. So let's see what we have here. I'm just gonna, these are relatively easy numbers to work with, so I'm just going to solve them for y. It seems to be more common for most people. So 6y is less than or equal to negative 2x plus 9. And I'll just keep going this way, dividing by 6. Y is less than or equal to negative 1/3 x plus 9/6, which is 3/2. All right, so the y-intercept is 1.5, and the slope is negative 1/3. So up 1, left 3, down 1, right 3, and that's going to be a solid boundary line. Solid. Always forget to change that back. we'll just do this one in blue. So solving for y, 2y is greater than or equal to 5x minus 18. Y is less than or equal to negative 5 halves x plus 9. So remember to switch the inequality since, oh, that's not a negative, sorry. That was my straight line. I was interpreting that as a negative. Okay, I'll fix that. So y is greater than or equal to 5 halves x minus 9. Okay, we'll start at negative 9 on the y. And do a slope of positive 5 halves, so up 5, right 2, and connect. And it will be solid. Okay, and then our final inequality is already in slope-intercept form. So we're good to go, starting to graph. We'll do this one in green. Y-intercept also negative 9. Slope of negative 4. Up 4, left 1. Dotted line. It's going to look like that. And now we do the shading, and we will be done with this one. So the red line should be below. The blue line should be above, below the red, above the blue, and also above the green. So everything in this triangular region, any ordered pair that comes out of that region will be the solution. Okay, I think we just have one more. And this is a line. Let's just do that one in blue. Solve for y. Negative 2x plus 6. Y is greater than or equal to negative 2/3 x plus 2. Y-intercept 2. Negative 2/3 slope. Up 2, left 3. Solid boundary line. There's that. And now this v is a little bit easier because this is a translation of the parent. The parent is y equals the absolute value of x, like we've talked about before. So that's the parent v that started here, but it's being shifted, or the fancy word is translated, 6 units to the right. So we'll do this one in red. So if you just take this original parent v and take the vertex, 1, 2, 3, 4, 5, 6. I didn't show up very well, but I think 6 is right there. And then just kind of slope of 1. It's easy to see on your graph paper. So from there you go up 1, right 1, up 1, right 1, up 1, left 1. And then you make your V, and it's also going to be a solid. Okay, and now we do the shading. So for the line, it's above above the blue, but it's going to be below the red V. Less than is below the line. So everything in between will be shaded. Above the blue and outside the red V will be, that's where we'll find our solutions, our ordered pairs that make both of the inequalities true. Okay, I think we've done it. That's all the problems you had to do. I hope this helps. If you have any questions about these, let me know.